Hello, my name is Claudia MASINI. I am a chemical engineer. I work in a multinational company that operates in the automotive industry, supplier of the major car manufacturers. My work experience for almost 30 years has always been in the automotive sector. Currently I deal with quality, environment and safety management systems, but in the past, I have held roles in quality and production area, and I have had to do a lot with materials, in particular with plastics, which is the subject of this course. The choice of materials is of fundamental importance for the success of a project. When choosing the material for the development of a project, factors such as the functionality of what you want to achieve must be considered. And it is only with experience that it is possible to identify the most suitable material for the project and the customer's needs. It is also important to have a thorough understanding of the transformation processes to identify the process parameters and processing procedures appropriate to the type of material chosen. In automotive industry, plastic has a fundamental value. Plastic material are in fact used for most of car components. For example, inside the passenger compartment, plastic is used for doors, handles, seats, dashboard. On the outside, for bumpers, grills, spoilers, with both a structural and aesthetic function. The choice of plastic in the automotive industry is linked to its characteristics. The main advantage is due to its lightness. A lighter car equals lower fuel consumption, but this without sacrificing performance, safety and comfort. To guide the choice, it is necessary to know materials, so we try to deepen this world of plastics which, since the last century, has had a very rapid and continuously growing development. What are plastics? They are all those organic substances obtained through chemical reactions of natural or synthetic products deriving from the chemical refining of coal, oil and natural gas. They are organic materials with a high molecular weight, made up of molecules with a very long chain. For this reason they are called polymers. Polymers are substances made up by very large molecules called macromolecules, consisting in repetitive subunits, monomers characteristic of the polymer itself, which are repeated in the same way hundreds or thousands of times. The type of monomers that constitute it and the bonds between them give the polymer specific and different characteristics. Plastic tree is a very suggestive representation of the multiplicity of existing plastic materials. The characteristics of the polymer suggest its use, but only its use defines its intended use. A macro aggregation of the polymers and therefore a classification can be made on the basis of their natural or synthetic origin, on the basis of the structure, of the thermal behavior, or even on the basis of the mechanisms by which the macromolecules are formed. Each of these aggregations serves to create homogeneous groups of materials with similar characteristics and therefore guide us in the choice. Let's take for example two groups of plastic materials used in the automotive industry, thermoplastics and thermosetting. The terms are explicit enough. Thermoplastics are plastic materials that soften under the action of heat, then return to being rigid by cooling, and the process can be repeated several times. Thermosetting, on the other hand, are plastics which, after an initial softening phase due to heating, harden because of the three-dimensional cross-linking effect. If these materials are heated after hardening, they no longer soften. Now, comparing the two groups of materials, we understand how the structure influences both the characteristics and consequently the use and the transformation processes. The multiplicity of existing plastic materials has given rise to the need to harmonize the nomenclature, also to allow the recognition of the materials of which the products are made in order to facilitate their selection and collection for subsequent recycling. For example, a nylon and glass fiber product will be identified and marked with the symbol PA66GF30 to indicate amide plastic, the type of monomer 66, the type of reinforcement GF. For I stands the glass fiber and its percentage in this case is 30. So, we understood how the characteristics of the material are the discriminating factor for choosing both use and the production process. So what are the characteristics that we need to know? The main characteristics of a polymer can be essentially divided into physical properties related to the behavior of the material in its transformations, mechanical properties, that is, the ability to resist stress, thermal properties, for instance heat behavior. All information regarding the characteristics of a plastic material are given on the technical data sheet. In addition to the main features, there are indications on the process to be used, on the storage and handling conditions. This is an example of a technical data sheet of a glass fiber reinforced polypropylene. For each characteristic there are nominal values, measurement units and test standards. Let's not forget safety, as the motto says safety first. Together with a technical data sheet, the safety data sheet of the product must always be present. A safety data sheet has a lot of information, but what we need to see are the danger symbols. In this case, for paint there is a risk of flammability and irritation. Harmonization and standardization involve not only the nomenclature but also test methods to characterize the various materials. Who manages this job is ISO, an independent, non-governmental international organization. Through its members, it brings together experts to share knowledge and develop international standards. A curiosity: the name ISO comes from the Greek isos and means equal. Whatever the country, whatever the language, it's always ISO. Other reference standards are issued by customers. In the automotive sector, standards are defined for materials to be used with a relative characteristics. The example specifies the physical and mechanical characteristics of a PP and the references of the standards to be used by both ISO and the customer. What information can a test standard provide us with? Let's take for example the standard for determination of flexural properties. You can see in contents information provided on the test environment, on the equipment to be used, on the specimen, and finally on the procedure to follow. At this point we have everything we need to take the test. Let's see how a test to determine tensile strength at break of a polypropylene according to ISO 527 is carried out in the laboratory.
La valutazione del carico massimo di trazione, che deve essere minimo 16 N su millimetro quadro, e viene usato il dinamometro digitale. Utilizzeremo il provino stampato a forma di farfalla. Viene posizionato il provino all'interno dei morsetti, bloccato. Blocchiamo le due estremità del provino, cioè cerchiamo che sia tutto in asse. Andiamo sul programma specifico della macchina, bilanciamo sia il carico che l'allungamento. Fatto questo possiamo eseguire la trazione. Adesso la macchina eseguirà un allungamento della traversa che tenderà a trazionare il provino. e durante la trazione rileva la forza a cui il provino è sottoposto. Adesso a un certo punto il provino si romperà e la macchina resta in ciclo. Il programma ha caricato il grafico e noi andremo ad analizzare il carico massimo di rottura, che è il picco massimo, e andiamo a rilevare, diciamo, i newton a cui è stato sottoposto, quindi sono 774 newton. 774 newton è il carico di rottura. La sezione del provino è nota, è 45 mm quadri, quindi facciamo 774 diviso 45 ed è uguale a 17,2 newton su millimetro quadro, che andremo a registrare, quindi 17,2, quindi supera il valore minimo richiesto, quindi è positiva la prova.
Thanks for your attention.